Hello all, I am Bhumica Verma, Assistant Professor in CSE Department in Ajay Kumar Engineering College, and today my lecture is about agent communication. So agent communication is basically the communication between the agent. Here agent is the word that is being used as a synonym or in the place of machine. That means here I am talking about how the machines are communicating to each other. So before knowing the term or before knowing the procedure how they communicate to each other, we must know certain terms or some topics that need to be prior understood about this term to be understand in the later part of the lecture. So basically the terms, the first course or the first needed requirement of this lecture is the agent and the agent technology. This means what is an agent, what are the different types of agent, how those agents work with each other, what are the terminologies or what are the components that are used in that agent technology. So we need to know about it in beforehand. And for this I have already made a lectures whose link is being given in the description box. You should check it first and then you can come again with this video. Then the second thing will be the agent architecture as well as the agent properties and the agent types, where architecture says that the agent architecture is of three kinds, that is reactive, deliberative and hybrid. Now what are these architecture? Reactive agents are basically the agents who those respond to the immediate stimuli from the environment and they take the actions based on those stimuli. And deliberative agents are the one they are more likely like a human that search through the spaces of the behavior, maintaining the internal state and also predicting the effects of the action as well. Hybrid is a combination of the above, and in that case they utilizes the AI to automate or digitalize the daily productions or income of any activity that needs to be done. Then is the properties of agent, which says about autonomy, communication, learning, reactivity, mobility and reasoning. Proactivity is basically the phenomena where the agent also think initially before going to do any activity. It will plan beforehand to do that activity. So that proactivity is the proactive, we have pro work done by the agent before going to actually start that activity. Then are the agent types that needs to be cooperative by nature, because all the agents that are involved here may be of heterogeneous systems. That means they are belonging to different domains, so they need to there is a need of cooperation between those agents. So these are the certain terms. Secondly, the second requirement is the knowing of our multi-agent system. So what are multi-agent system? So as the name suggests, there are multiple agents that are involved in this kind of communication, and these multiple agents may be or may not be belonging to same domain. That means they could be of the same domain as well as they could be from the different domain. So in that way they need to be communicated. They need a coordination between each other. They need to negotiate each other, or they need a mutual agreement to do certain activity, because as they belong to different domains, there might be a possibility that there may be some issues, or you can say fights between them, that they will do their work, that he will do its work, but there needs to be a cooperation and negotiation between them. And finally they'll come up with a distributed planning with that work, and finally a coalition will be formed. That means a unanimous government is being formed by those agents to come to a unanimous or a unique plan from all the agents. And finally the application domain needs to be known in prior to go to the agent communication. So after knowing all these prior terminologies or the prerequisite information that I have discussed here, my today's lecture's overview is about the collaborative agent, distributed problem solving, agent communication, where agent communication are of two types, that is blackboard system, message passing, FIFA standards and basic communication protocols, where I'm going to take up only the blackboard system and message passing, the standards and the communication protocol. I try to cover up these topics in my next lecture. So starting up with this, what is collaborative agent? So as the name suggests, that collaborative agent is the one that collaborate with each other. So there are multiple types of agent, there are multiple kinds of agent over here that seems to be in the collection, and those agent collaborate with each other. Again, this possibility is same, that these agent must be belonging to same domain or different domain, but still they are collaborating with each other. They can communicate and cooperate with other agents while keeping their autonomy. Autonomy is basically simply they will work their own, because all the agent is assigned their individual work, so their target is to achieve that particular goal. But since they are in a collaboration, so they needs to mutually do the target as well, and and the collaborative work as well. So that means they need to keep their autonomy. Finally, they'll be able to negotiate with their peer members or peer agents, and they mutually come up to a agreement that they will behave in a cooperative manner for any kind of problem solving. So there will be cooperative problem solving between those collaborative agents. So they will work as like this in the picture, they will work hand in hand with each other. Then is the case why collaborative agent is required. What are the motivation behind this collaborative agent is required? So the first motivation, or basically the main motivation, is that we need to solve a too large problem. So if I'm taking a single agent at a time, so that agent will be too burdened at a time, or that single agent will be too overcome by the problems, and it will be too large to solve that particular problem at a particular moment of time. So that huge amount of knowledge will be required for that, many kind of computational resources needed for that, and there will be various risk factors is involved in that centralized system. So this will be the first and the main motivation behind using this collaborative agent. The second motivation will be that if I want to create a system that works beyond the capabilities of any of its member, that means if I work with only one agent, that agent will be trained for particular one job only. But if I am collaborating various kind of agent, then I can utilize the power of all the agent, and I can work collaboratively. I can use collaboratively the power of all the agent into my work, so that I can easily add on the functionality of any of the system that I need to design. Thirdly, it allows the interconnection and interoperation of the existing legacy system, that is I am adding value additions to the expert system, or any electronic equipments or sensors that need to be modified by time. Then these are the real-time applications of collaborative agents. So first application is the solution to the physically distributed problem. Physical distributed problem means, for example, if there is a disaster in the city, so at that time, not only the police is required, not only the firemen are required, not only the ambulances are required, whereas all these three departments or certain other departments also, they need to collaborate with each other so as to come up to the solution for that particular problem. And how they overcome with the situation, they need to collaborate with each other. In that case, collaboration of these human agents are required at the uttermost importance. Second is the sensor network monitoring in a given area. That means distributed data sources are required. In that case, they need a collaboration between them, because if they are fetching the data at particular time, if the information is outsourced or that is obsolete, then it is of no use. So every time they need to be collaborated, and they needs to be updated. Thirdly is in the case of when I need distributed expertise. That means, for example, if a person need a healthcare provisions, in that case various kinds of human agents are involved. Family doctor, nurses, specialists, or laboratories are involved, so as to provide a solution to that particular person. So these are the real-time applications for this. Then what are the benefits of multi-agent system? So first one is the modularity. The common example, the common advantage is the modularity. Modularity is none other than the simple term that I'll divide my problem into sub-problems. The process of solving a complex problem, and it will be solved up to some sub-problems. In this way, the complexity of the problem is reduced, and you can increase the factors of reusability. Second advantage is the efficiency. If the problem is divided into sub-problem, then it will be more quicker to solve. That means various agent or various problem will be divided into various kinds of agents, and they can solve those problems parallelly. In that case, working time is reduced, and they'll be able to share the partial result, and they'll be more easily coordinate with the shared resources as well. The third advantage will be the reliability. Reliability is basically when a team is being made. That means if a collaboration is done between the agent and one work is being decided by an agent to be done, in that case, if particular agent fails, then other agent take its work and redistribute it dynamically. That means the system will not be affected by the failure of only one particular agent. So to this avoid the single point of failure in the centralized system also. The fourth advantage is the flexibility. Flexibility is basically when an agent dynamically generate the subtask and they ask any of the agent or any of the other agents for help or to look out into the matter. In this case, different skills may be added dynamically. Different agent can be created or deleted dynamically depending upon the amount of work to be done or the available resources that I am left over with. So basically these are the advantages of using a multi-agent system. Then this picture symbolizes the disaster in a city, which I am talking about in my previous slide, that if there is a lack of coordination between any of the agents, here in this scenario, I am talking about the human agent. That means here ambulances are involved, here police is involved, here helicopters or medias are involved. So if they are collaborating with each other, they'll be able to easily cover up all the information, cover up all the news regarding this. If they are not collaborating with each other, then they will not able to get any of the information, they will not able to solve any of the problem, and in that case the city will be completely in a mess situation, which is depicted in the picture. So collaboration is needed at the uttermost importance. I have told you that thing. Then after all these collaborations, after all these agreements that all the agent will work in a collaborative manner, finally they come up with a distributed problem solving in which the agent work together to solve the problem that requires some collective efforts. For that collective effort, because they are mutually agreeing to do something, so that for that collective effort they require two terms, that is the coherence and the competence. The coherence is basically that they want to work together, and competence is basically how they work together. So finally, when they agree on these two terminologies, then a distributed planning is being done. That means agent work together to construct a particular plan. Then the problem solving, which I'm talking about, distributed problem solving, is being divided into these steps. This is task decomposition, task allocation, task accomplishment, and task synthesis. Task decomposition is basically task decomposition is basically the decomposition of task into subtasks. This is the common term that we are learning from so far. That is any of the tasks which is being divided into subtasks. That means task is totally independent, having some independent behavior, and the large task is divided into subtasks. Divide the common complex problem into the set of tasks or some hierarchy of sub problem. In that way, I am able to draw a chart like a central coordinator will be here, that is having two of its subtasks. These tasks are further divided into subtasks, and further on I am able to divide all the tasks into subtasks until at that level, so that this particular last level will not be further subdivided. So in this case, the task will be decomposed, and it will be similar to any of the graph that we have studied so far. That is in the case of tree formation or tree graphs, or I am saying about any of the hierarchy systems, or any of the AND OR graph that we have studied in the AI also. So this will be very similar to any of the graph which is depicted here. Then the second term is the task allocation. So after that allocation, after the decomposition of all the tasks up to various levels, some agent is being assigned to those particular tasks. So that means task is being allocated to the particular agent, assign the sub problems to different agents, so they'll be easily able to solve those problems, and every individual agent has its sub problem needs to be solved. Then finally the task will be accomplished. That means the agent as they have different domain, as they have knowledge enough or skilled enough to do solve that particular problem, so they solve that particular problem in that moment of time, and finally the task is being done. But this scenario is not simple as it is looking up, because there will be two scenarios. If the processes or if the tasks are independent of each other, then there will be no issues and there will be no communication with any of the agent. The agent is independent of each other and they can perform or they can work on their own task. But since there could be dependencies between the sub problems, so agent need to be communicated. In that case, potential conflicts may occur. Conflicts will be there. Now these conflicts may be in the form of, as we have seen in the case of deadlocks, that there might be certain processes, like the scenario is same. If there are two processes, that is P1, that is P2, and they require some resources at that time. Here the process is holding on the resource 1 and it is also demanding resource 2 in that case. Here P2 is holding on the resource 2 and it is demanding for the resource R1 as well. So this is a case of deadlock, or this is one of the case how the conflict is being arised. So this is the case, this is the example that there may be use of shared resources, and maybe the sub problems or the sub solution provided may be incompatible by nature. So in that case, agent needs to be properly communicate with each other to solve this situation. For this, there might be different solutions for solving these problems. So solving these problems or these situations, some kind of agent support is needed. How the agent are supporting to each other? So first thing is they need to share the task. For sharing this task, the agent coordinator asks the other agents to solve their problems. For this might be due to, because single task, if the coordinator provide individual task to certain new agent, then it will be too complex or expensive for that agent to do it individually. Secondly, the second reason for taking the help of other agent is that it may be possible that particular agent must have solved that particular task or sub problem, or it may be the possibility that other agent have the appropriate knowledge or skill to solve that task. In any of the cases, basically the coordinator decide that it will ask for help from other of the agent. Finally, after deciding all up which task is to be assigned and to whom it is assigned, that task is being assigned. And after that, result is being shared. The second support needed done by the agent is the result sharing. Result sharing is basically when it uses the intermediate result obtained by the other agent. That means agent can provide the intermediate sub-solutions. This is simply as if I am solving a problem, if I am solving a complex problem which is further divided into sub-tasks, and suppose I am stuck up to this level. Suppose I am stuck up to this level. So instead of starting to solve this problem from the very beginning or from the scratch, it is recommended that I should start it from the level up of that problem. That means I will start from here. So the coordinator will decide the help of this agent as well, and it will try to reach out up to these levels, so that the approach is very common and very knowing that the coordinator wants that other agent that is directly or that is very nearby to that particular problem or that particular agent will help into this matter or will look out into this matter, because he assumed that these agent is having some kind of information about the scenario what happened here. If he asked the help for these agent, that means these agent are very far away from that situation, so they may be unaware of that thing. So basically the central coordinate decide that which agent to choose and to take the help from. And finally, for resolving this conflict, a care is being done. The care is in the form of that proper communication is being done. Actively listening between the agents is being done. Then review option, that means after conflict is being arise, the reviews is done in a very even manner, a very positive manner, and those options will be taken up very positively and very intelligently, because they are looking for the solutions that benefit everyone. And finally, and E stand for that in the end there will be win-win situation to all of the agent. That means they'll be if I'm talking about the profits of all of the agent, that means that profit is being evenly distributed among all of the agent as well. So this, in that case, conflict has been resolved. And finally, after the completion of all these conflicts, the conflicts have been resolved, the last step is the result synthesis. That means all the processes or all the sub results of all the sub tasks done by various agent will be put together as a result, and then finally a complete solution is being derived. If not, then at the end again a conflict is being detected. If any of the conflict is detected, then again the task reassignment is being done, and this process will go on in a spiral manner until all the conflicts occur in the situation is resolved. So fine. So these are the distributed problem steps. Then the third important topic of lecture is the agent communication. That means how the machine is going to communicate with each other. So basically there are two different options in a MAS, multi-agent system, in which the agent will be able to communicate. The first one is the blackboard system and the second is the direct message passing system. So blackboard system, as the name suggests, is the very common name which is used in education system in our day-to-day life. That means if I'm a teacher, I am using a blackboard in my lecture as well. So that means the agent communication is very similar to that education system mechanism where I am using the agent is using the blackboard. So similarly, as the blackboard says, that means here is the blackboard and every other agent which is coordinating with that thing, and every agent is being communicating or listening to that blackboard activity time to time, and all the information is being depicted here. That means blackboard is acting as a broadcast medium, or I am displaying publicly something, or I am displaying publicly some information on that board, so that other agent which are connected to or communicating with me or the agent will be able to read out those information from the board as well. In that case, all the information is being kept on the board, so all the agents could read those information from the board, and these agents could also able to write the information on the board. Secondly, these agents can only communicate with the agent of the blackboard only. They could not communicate with each other. This communication is not possible here. That means if I am teaching in a class, I am reading or I am writing any information on the board. If the students are sitting in front, then in that case the students could only able to read that information from the board. If they want to read something and if they want to write something, they go and write the information on the board as well, but they are not they could not able to communicate with each other. So this is blackboard system. So each agent can put the information, data and knowledges on the common information spaces, then they'll be able to read all the information from the board, and there is no direct communication between the agent, as I've already told you that thing. Then what are the uses of why we are using that blackboard system? That means this is because I can easily able to detect those conflicts. That means if different agent want to perform the same task, then it will be very easier for any of the central coordinator to detect that the conflict is going to arise, so it will be able to resolve that thing, and it will be resolved at the scratch level only. Then it will also be easy to notice all the incompatible solution. That means if any of the shared resources is being demanded at the same time, so it will notify the incompatible solution, and also it will be able to use to share the results and also share the task, which I have already discussed in the agent support in the previous 2 slides. Then what are the information that is kept on the blackboard? So these might be data of the common problem, this might be some kind of current state of the solution, this might be any next sub problem that needs to be solved, it could be any request, it could be the present task of the agent, it will be any intermediate result. So all of these information, this could be of any of the information will be we will be able to display on that board. So in short, the positive or the advantages of using the blackboard system is basically the flexible mechanism, because this is the simplest approach and this is the flexible approach in which we allow various communications of we allow the communications of various agent, and no cooperations is needed among all the agents, and this thing is also independent of the cooperation strategies also. It does not place any restriction on the internal architecture of the system. So these are the positive aspects. That means I need not to think about that what are the basic traffic jams or what will happen in the communication. I just put out all the information on the board, and that information is being read by the agents from the board as well. So this will be the very simple and cheaper usage of using the blackboard system. Secondly is the negative aspect. Negative aspect is basically it is a centralized system, because it is a common platform of showing of all the information. So as the picture depicts, that if the children want to say something or to display any information, that means some students are reading those information from that particular board, and some students are writing some information on the board. So it will become a mess at a particular time, that if this child is able to read any information from the board, so it will be very complicated for that particular child to read the information from the board, because both of the happening is happening at the same time. That means both of the activities are happening at the same time, reading and writing as well. This position or this situation is very similar to the situation of conflict serializability in DBMS, or when I am saying that a transaction is being done but that transaction is in process, so I'm not able to detect that whether that transaction is incomplete or it is completing. So this becomes a centralized system and a bottleneck for the system. Then if everyone is writing the information and if everyone is reading that information, a single point of failure is always there. So this is the negative aspect of using the blackboard system. Next is the message passing. The second way of communication is the message passing. As the name suggests, that messages are being passed from one agent to another agent. Here, first agent is acting as a sender and another agent is acting as a receiver in that case. So information is basically passed from one agent to another. So the nature of this information can be varied. This variation require various kind of rules. That means agent uses the message to send the selected data. Agent will decide the selected data to be sent, and it will decide how to send and to whom it will send that information. For that particular thing, it values in that message that what needs to be exposed. That means what are the features it want to expose or to send to further agent. The third thing is the channel. That means I'll try to figure out what will be the routing modes of that particular thing. This is very similar to the concept of networking what we have read in the computer networks. That means if two system needs to communicate, then a networking is being set up between those, and for that particular thing routing is being decided. That means if I'm able to do the direct routing, or I'll be able to do the signal propagation routing, or I'll be able to broadcast that routing. So that channel is being decided, and finally the target is being decided to whom I want to send that particular message. For that particular thing, this message is incorporated of the message itself and the header, in which I'll write the sender address, and finally the footer includes the destination address to whom I want to send that particular thing. That all these header footer are very similar in the case of that we have read in IP version 4 or IP version 6, in which the message is being incorporated by various other formats, and finally the message is being sent from sender to the receiver. So this message passing is of two types, that is direct message passing or indirect message passing. Direct message passing is that simply when I am passing a message from sender to receiver and it is being directly sent. Here the sender knows the destination address and destination knows the address of the sender as well. In that case, it exhibits the symmetry addressing only. The send and the receive parameter will be like send parameter. Here P is the process to whom I want to send the particular message. And indirect communication is the communication in which there is a sender and there is a receiver, but the communication is not done directly, but it will be incorporated or having a intermediate person or system or agent in between, or you can say a facilitator in between. This is a facilitator. So for this communication, here the information will be sent to the facilitator, and facilitator will further send this information to the receiver. The reply is again come up with this protocol only to the facilitator, and facilitator again to the source. And this is the indirect communication media that is basically being used in the RPCs in operating system. That is when I'm doing any remote procedural call in operating system. So basically a phenomena of intermediate agent or intermediate nodes is being used here. So in that case, the message are sent or received into some kind of mailboxes. These mailboxes can be viewed as an object into which the message can be placed and from which the message can be removed. So there will be a repository in between the sender and the receiver in which I am placing my messages, and further on, if I am not willing to do or to retrieve it further, I'll able to delete those messages in that repository also. The primitive will be like send a message. Now here A is the mailbox which is acting as a facilitator in between. So this is all about the message passing, and the other FIFA standards and the communication protocol I'll try to make a separate video for that, and I'll try to figure out those problem in that particular lecture for all that thing. Now, as of now, this is all about the agent communication. I hope that you have liked the video. So thank you so much for watching.